Everything in this chapter comes together in one small program, and it is a program worth actually typing in and running, because it answers for your machine rather than for a table in a book. 3 headers, stdio.h for printf, limits.h for the integer bounds, float.h for the floating point ones. Then 1 printf per type, each printing the name, the size from sizeof, and the minimum and maximum from the header macros. A few details in the format strings are worth pointing out. The dash inside a conversion, as in %-14s, means left justify in a field 14 characters wide, which is what lines the columns up. The %edu prints the size _t that sizeof returns, exactly as we discussed. %ld is needed for long, because long and int are different types and printf has no way to check. FLT_max is cast to double because a float passed through the ellipsis is promoted to double anyway, and %g expects one. And %g picks the shorter of fixed and scientific notation, which is what you want for a number like 3 times 10 to the 38th. Now, what should you look at when you run it? The exercise is really to run it in 2 places, your machine and a classmate's, or your desktop and a Raspberry Pi, Windows and WSL, which you already have installed from Chapter 2, and compare the output line by line. Long is the row that changes, 4 bytes on Windows, 8 on Linux and Mac OS, exactly as we said several lessons ago. And seeing it with your own eyes is worth more than being told. The char row is quietly informative too. Look at char_min. If it is -128, plain char is signed on this platform. If it is 0, it is unsigned. That single number answers the question from the char lesson for the machine in front of you. And look at the float row. The maximum is enormous, around 3 times 10 to the 38th, which surprises people who expect float to be small. Range is not the thing float gives up, precision is. It can represent gigantic numbers, just not very many digits of them. This program is essentially src/beginner/03_datatypes.c, which comes back in Chapter 17.